So what is the official verdict on the principle? So this was my unofficial principle, right? So what is the actual, honest to goodness, principle of refrigeration? Number one, liquids absorb heat when they change. What do you think I should put in this fill in the blank? How can I get a liquid to absorb heat? Oh, you change the state. So what do you think? When will it absorb heat? So you're right, it has latent heat, right? When will it want to absorb heat? So there's three states, right? Solid, liquid, gas. When it goes from a gas to liquid, it wants to absorb?
No, when it goes from liquid to gas, it wants to absorb heat.
Right? Because that's how it converts. So in order to go from a liquid to a gas, it needs to absorb heat. Excellent. Go from a liquid to a gas. Also, can the same happen when it goes from the solid ice to a liquid state? Right? Anytime it changes a state, it either absorbs or it gives off. Okay, so on the other hand, sorry, I'll get back to you in a second. Number two, my next question will be gases give off heat when they change. Fill in the blank. Think about it for a second. I now need my gas to give off heat.
When they go from gas to liquid.
Right, and what do we call that process?
Condensation.
Condensation, right? When it condenses. So yes, when it changes from a gas, from a gas to a liquid. Will the same happen when I go from water to ice?
Yes.
Right? But then why don't I use the state solid to liquid in my refrigerators? And also, what happens to water when it actually at between like 4 degrees and 0 degrees, right? It expands. Is that a good idea to use that? Thinking about it, right? So that's why we don't use those states. But again, just remember the same process will happen whenever there is a change in state. Okay. So most refrigerators and air conditioners use what is called what is it called? A working fluid. Yeah. What were they? Chlorofluorocarbons that they used to use in the 70s and the 80s? The CFCs, and now they use hydrochlorocarbons and whatnot. Yeah, there's many things that are now being used, right? But what should they all have? What should all working fluids basically have? Okay, think about it this way. So what do we call that state in which a solid changes from liquid to gas? Liquid changes from a liquid state to a gas state. What does that point call it?
Boiling point.
Boiling point.
So you want to have a low boiling point.
Yes. So what if something has a boiling point of 1,000 degrees? And something else only has a boiling point of your hand. Remember we saw that picture, we saw that device?
It's a lot easier to work with than to get to evaporate. Or
Yeah,
to-
like that. Do you remember me showing you this? What happens to this when I touch it? What's going on? Oh, it's empty. What if I touch this? Oh, see, bubble, bubble, bubble. Look at that. What can you tell me about this by me just touching it? It's a very low boiling point, right? My hand would be what, 100 degrees Fahrenheit? A good day, 97, right? Look at that. It's actually boiling and going to the other side. It's evaporating and going there and then liquefying there. But you see that? Will this be something you can use as a good working fluid?
Yes.
Because it has a very good property that it literally evaporates by very, very low work input from me. Okay. No.
Dr. Zane,
Yes, sir.
one thing that happens like with CO2 canisters and stuff, whether that's for like paintball or airsoft or anything like that, if you like let off all the CO2 at one time, it gets really, really cold, like the canister, which is fun for like cooling off on a hot day if you need to. But like it's that same like liquid to gas transition.
It's the same thing like if you put your drink out, what happens to it? It sweats. Where's that coming from?
Condensation from the air.
Environment. Yeah, that's exactly what it is. So what are the criteria for our working fluid? What is one? Must have low boiling point. Great. Why should it have low boiling point?
So we can work with it.
Yes, because as always, what do we want to do least of? What is the universe inherently? No one wants to do more work than required. Well, yeah, that might be true. But because we all want to do less work. Less work means more efficiency. And we also, number two, now want it to not kill us. So how do I say that politely? Not hazardous
You're telling me you don't.
to humans and or nature. This is why things have been developed over the years that are now illegal. Until we find out that even those have problems, and then something else comes along. There is another third reason, and that's called critical temperature. What is critical temperature? Critical temperature is that certain temperature above which, no matter how much you try, a refrigerant cannot be liquefied, no matter how much pressure you apply. How do I say that correctly? Okay, TC is the temperature above which the refrigerant cannot be liquefied no matter how much pressure is applied. So think about it. Do you want your critical temperature to be very, very low or very, very high? Take a second. So it is a temperature above which, no matter how much pressure you apply, you cannot liquefy it. You want it to be really high or really low? You want it to be really, really high. You want the boiling?
A low boiling point, but high critical temperature.
Exactly. So you want that temperature to be very high so that you have a lot of room in between your boiling point and your critical temperature. Does that make sense? If they both reach very quickly together, then you're going to be in trouble. Especially when you're thinking about refrigerations and stuff, right? You have that nozzle in which there's a pressure difference and you want to sneak that into it. You want that temperature to be very high. So this should be, TC should be high. So what happens if it's not? Two bad things will happen. One, your refrigeration won't last very long. And two, even more, you will require more power to make your refrigerator work. Which is why if I had water in there, in my little device, the toy device, what will happen? How hot will my hand have to be for that to occur? For evaporation to happen? Instead of 100 degrees Fahrenheit, my hand must be Fahrenheit or 100 degrees Celsius. Yeah, 212, right? Isn't it 212? Right, yeah. 212. That's correct. So how much more energy will have to input to make it work? But as we all know, the universe is inherently. Do I want to do more work? Absolutely not. Never. Never, ever, ever.
So you're saying we shouldn't do work?
No, I said the universe doesn't want to do work.
I'm part of the universe.
No, you're Amanda.
You just don't want to do work. You have to.
Not part of the universe.
All right.
I'm done.